Hello there! Today's video lesson is a little bit different than other video lessons in that I am giving you a warm-up question. So I'm going to go through this and then we're going to start what this lesson is about. But this is just a solving question. It is not a graphing question, so you don't have to graph it. You don't have to sketch it. You just have to find the, pointing to this, degree 3, so you have to find the 3 possible answers. So you're hoping for 3 distinct answers, but maybe there's others, and because you're not graphing, nobody cares about what the answers are. Even the I complex numbers answers are just fine. Now I want to do something a little crazy to begin with, and that is I want to test the old Wayne Gretzky lightning bolt method. So if I try this, I can take an x squared out of the first two terms, leaving me with x minus 4. And I can't take anything out of these two terms, so I'm going to take out a positive 1, leaving behind positive x, and 6 divided by 1 is 6, equals 0. And do you see these two brackets? They are not the same. That means this method is garbage. You don't get to do that. So I have to erase all of it. Bigger eraser. I have to erase all of it and start this kind of old school. So the first thing I have to do is state that this is my f at x. And then I'm going to have to find a number that divides into 6 that will give us a 0. So if I look at this, 1 minus 4 plus 1 plus 6 is not 0, so 1 doesn't work. I'm going to take a wild guess and see if negative 1 works. Remember, you likely will not have to go through the whole list to find one. Get yourself a system. So negative 1 cubed is negative 1. Negative 1 squared is 1 times negative 4 is negative 4. Positive and negative 1 is negative 1 plus 6. So there are 6 negatives, so negative 6 plus 6 is 0. So my guess was right, which is pretty good because I didn't want to do a whole bunch of stuff and erase it again. So that means that I have found one of the 3 possible factors. So I found that negative 1 gave us a remainder 0 using the remainder slash factor theorem. And that means this is a bracket, the opposite. This is a bracket that when you use it as your divisor, using x cubed minus 4x squared plus 6 plus x plus 6 as your dividend, it should give you a remainder of 0. So I'm going to take this space just so that I can visually see everything, and I'm going to do my long division. Now, the nice thing about my long division and eventually my synthetic division, remember you don't have to do both, is that it's all in descending order with no gaps to fill, so I'm all good. So no chance of screw up except for maybe these mistakes. So x squared, x cubed, plus 1x squared. So those will cancel out. Negative 4 minus 1 is negative 5x squared, plus x plus 6. Bring that stuff down, divide again. Multiply around, yay they match. That means these will subtract out and I don't need anything here. This is where I have to be super careful. So I've got 1x minus negative 5. So that's actually plus 5, which means it's 6x, bring down, divide in one last time. And no surprises that this has a remainder of 0. Now, I'm going to do the exact same thing for those of you who like to synthetically divide, just so you have the solution nicely here. So you go back to using the -1, the opposite of the number in the divisor. So 1x cubed, -4x squared, 1x plus 6, drop the first digit, multiply, add, multiply, add, multiply, add. No surprise that we have a 0 remainder. This was an x cubed. That makes this 1 degree less, so an x squared, this 1 degree less, this 1 degree less. So my division statement, sorta division statement, is x cubed minus 4x squared plus x plus 6 equals 0 will change to x plus 1 multiplied by x squared minus 5x plus 6 equals 0. I got that either from the quotient of long dividing or the quotient of synthetic dividing. And I'm pretty excited again because I'm looking at this simple trinomial and I don't think I need the quadratic formula. I think that that's factorable. So I need two numbers that multiply to be 6 that at the same time can add or subtract to be -5. So I end up having 3 distinct brackets. That means I'll have 3 distinct answers. And just to maintain the system that I've been using all the way along, I'm going to show that green line that will annoy some of you. And my final answer is x equals -1 or +3 or +2. So +1 on the other side, 1 minus 0 is -1, plus 3 will give us 3, plus 2 will give us 2. And that's our answer. I'm not asking you to graph, I'm just asking you to solve. So it doesn't say sketch, it doesn't say graph, it doesn't even have a y equals or an f at x equals. So that means you get to stop right there. Now, I am going to put up the next sheet. Remember that you can pause at any time, and this stuff is printable because I will give you a note. I'm going to put it on full screen, and then I'm going to make it pause for a while, and hopefully you'll notice a pattern between this warm-up question and the question I'm giving you right here in slide number 2. And notice I've got a blank for slide number 3, and then we've got a bunch of 4, 5, 6. So we've got a bunch of questions here. So this may take a bit of time to go through this note. This note, even though we started with a warm-up, is called Solving Inequalities. So we got to figure out what an inequality is, and I'll come back to tell you all about that. So there is the entire set of steps if you are a step person. I am going to also go through them while we finish this question and maybe add in a couple of notes as we go along. So for now, take yourself a little break, or at least let me have one. So I've done my little hand stretch, which is nice. And now we're going to run through some of these steps. Eventually we'll go through and take care of them one by one, but we'll see how far we get, and maybe I'll put this on a wider screen so I can show some work. So the first step is to pretend that the inequality is an equality. That means you're going to use an equal sign. Now, as I said, these are inequalities, so we're solving inequalities now. They're still polynomial, because there's all sorts of inequalities. This one is a polynomial inequality. And an inequality uses this sign, or this sign, or this sign, or this sign. An equality uses an equal sign. So we're not doing equalities now, we're doing inequalities. Now that doesn't change it by tons, it just changes it by a little bit. Before I start, I'm going to give you a little memory aid. Before I start the question, I'm going to give you a little memory aid. If you have this symbol or this symbol versus this symbol or this symbol, this one is a less than sign, and this one is a greater than sign. Now I remember that because this kind of looks like an L, so I can actually build less than right into it. This part right here gives you the or equal to. So this sign in its entirety is greater than or equal to. You can't be greater than and equal to, and you can't be less than and equal to. It's one or the other. So now you know how to read this, which took me to grade 11 to figure that out, and I became a math teacher. So the first thing I want to do with this question is I want to pretend for a second that this question is actually x cubed minus 4x squared plus x plus 6 equals 0. So that's step one, is either writing it down so you can convince yourself that it's like that, or imagining it. And then step two is to factor and solve like you normally would. Now I'm kind of hoping you're looking at this question right here, and it reminds you an awful lot of this question right here. In fact, it really is, because all this work I had you do in the warm-up is exactly what you would need to do step two and find x equals -1 or 3 or 2. So I'm going to leave a little space here for a little notation, but x equals -1 or 3 or 2, double check I don't want to make any mistakes, I have that right. And the little notation I'm going to make to myself is, or to you, see page 1 of note. All right, so I'm going to teach you two ways of taking care of the inequalities. That's why I have 2 pages for this. I'm going to put this on full screen now as promised, so you're not going to be able to see everything. So I've pretended that the inequality is an equality so that I could do all the work that I did on the previous page, and I could find the answers to the and solve part of the inequality. Next thing, I have to draw myself a number line. So if you need a number line, there is one in the classroom in case you're in there right now. If not, like I said earlier, you could Google it. So you make yourself a number line. Now you do not have to be accurate. This again is a sketch, but this represents the x-axis. And it says to draw a number line and place these roots, these answers, on the number line. So all you have to do is make sure you put it on in numerical order. So what I mean by that is that -1 is going to go here, and 2 is going to go here, and 3 is going to go here. Pretty please don't put 0 on. I know that 0 is nice to know where it is, but don't put it on there because it will mess with you at some point. So just put on the numbers that you find for your roots. Then it says, if the symbol in the original question was less than or greater than, then we get to circle the roots. So I'm not looking at the original question yet. I'm going to circle these roots. By circling the roots, I mean toss a circle around them. Then it says if the symbols are less than or equal to, or greater than or equal to, then you circle them. So you circle them either way, and you color it in. So our job is to figure out, do we color in these circles or do we not color in these circles? And because this does not have the or equal to, That means we can leave them uncolored. So I am done step 3. Step 4 is kind of annoying. Step 4 is super necessary if you're going on to take a calculus class either next semester or next year. And that is a check system. So this is not my preferable way of doing the question, but this is something I like to teach in advanced functions so that people going on to calculus have a clue and have seen something twice rather than once. So we have to check values in and around the roots. By that I mean I need to check values in those spaces. So I've got 3 roots, I'll have 4 spaces. And if they make the statement true, then we have to color in the area that we checked. If it makes a false statement, then you don't get to color at all. So I have to find a number out here, and I'm going to pick the number -2, and this will be x equals -2. I have to pick a number in here. I could pick -0.5. I could pick 1. I'm going to pick 0. I need to pick a number in here, kind of unavoidable. I have to use a decimal. And I need a number out here. So I could pick x equals 47, or I could pick 4. Because all we're looking for is a true or false statement. We're not looking for anything that has a value. So I'm going to erase all this stuff as I go along. And I need to put that in here. Now you do have an option, and that is, instead of putting it in there, you could put it into any one of these. So I am going to choose, I'm just stealing my work, I'm going to choose a little bit of everything, because then you get to decide which one you want to do. Eventually I will also erase this, or I'll box it up and make it a little less obvious. So the first thing I'm going to do is I'm going to use -2, and I'm going to put it into this bottom line. So, time to do my checks. So first thing is, I'm telling you what I'm checking. And then I'm going to put -2 in for all the values. This should not be an equal sign, even though I have an equal sign here. This should be the less than sign that's in the original question. You have to decide if that is a true or false statement. And that says -20 is less than 0. And last time I checked, -20 really is less than 0, so that's a true statement. So that means I get to color. Then I'm going to put 0 in. Now I'm going to tell you I'm going to check 0. And this time I'm going to put it in here. So that means 0 cubed minus 4 times 0 squared plus 0 plus 6. Again, less than 0. So that's 0 minus 0 plus 0 plus 6 is less than 0. So that's 6 is less than 0. And last time I checked, 6 is not less than 0, so that's false. And I do not get to color. So next thing I want to do is I want to put in 2.5. Or whatever other value you pick. So if you pick 2.6, you're either still going to end up with a true or a false statement depending on what it actually is. So let's put it in here. Now this time I'm going to show you a trick, because I'm not a big fan of decimals. Especially since my calculator is, I don't know, across the room, at the bottom of my bag. So I'm choosing to put it back in here. And here. And there, and also remembering that it's less than 0 in the original question. So, I'm going to do a little cheat this time. These, I put it into the factored form. So these things right here, when we figure out the contents of the brackets, they'll be multiplied together. And there's multiplying rules for positives and negatives. So all I have to do is figure out what sign this has. So 2.5 plus 1 is 3.5, and 3.5 is positive. 2.5 minus 3 is negative 0.5, so that bracket is negative. Then 2.5 minus 2 is positive 0.5. And I have to figure out if a positive multiplied by a negative multiplied by a positive is a positive or a negative. And it's a negative. So we have to figure out if it's true or false that negatives are less than 0. And that's true. So I get to color where the 2.5 was. Now this is leading up to calculus. So this checking, very calculus-like. So the last thing I'm going to do is I'm going to put 3 in, but I do want to tell you that I'm going to do a lot of imagining here, because it's not because my hand hurts, but my hand does hurt. And I sort of lied to you. We're not allowed to put -1 or 2 or 3 in. We have to put our space numbers in. So I'm actually putting in 4. And here's what I have to do to imagine it. Do not try this little trick for standard form. You can only use it for factored form, because factored form implies multiplication. So I just need to see that. So I'll have 4 plus 1. I'm not going to write that down. I know that 4 plus 1 is 5, and 5 is positive. 4 minus 3. 4 minus 3 is 1. I know that 1 is positive. 4 minus 2. 4 minus 2 is 2, and I know that 2 is positive. And if I were to take a positive multiplied by a positive multiplied by a positive, I would get a positive answer, and I have to figure out if that positive answer is less than 0, whether it makes a true or a false statement. So positives are less than 0. No, that's not true. So it's false, and I don't get to color in anything at all. So what I need to do now is I need to make a therefore statement, because that is step number 5. So I've done all the annoying checking, and as you can see, you can make it less annoying if you want to. But I'm going to give a therefore statement. Now the thing is, a therefore statement for this, you could do it in 2 ways, and that's kind of unfortunate. I'm taking this downstairs a little bit. Let's see if I can do this right. Not right. So I'm going to clone. And I'll take it downstairs to make my therefore statement. So this topic is very much related to the other topics that we were doing. It all kind of blends into itself. Now I'm going to give you 2 different therefore statements. You're going to have to bear with me, and this will probably take the length of the note to figure out in its entirety, and if you still have problems, please ask. I'm going to show you the high school way of writing this, which is actually the more complicated way, and then what I'm going to call the university way of doing this, which is actually less complicated. You might have seen both in grade 11, but I'm not 100% sure. So I'm going to do this in blue just to mix things up a little bit. And really, it's not called the high school way and the university way. Instead, it's called set notation, and the university way is called interval notation. Now, before I forget, what this picture is showing us is that if we take any number that is to the left of -1, so less than -1 but not equal to it, and we insert it into this statement, you will arrive at an answer that is less than 0. If you take a number between 2 and 3, you will also get a true statement. But if you pick a number between -1 and 2, or a number that's bigger than 3, you will get a false statement. So that's what that's saying. So there's billions and billions of answers because there's billions and billions of numbers out here, including all the decimals, and there's billions of numbers in here. So this is unlimited, so you have a ton of answers to this as opposed to an equality, which are only the answers that you get when you solve it. So I've got the picture down here again. And I'm pretty sure that at some point I will be able to convince you that university way is the easier way of doing it. But to start the high school way, you start with this every single time. So that says we're talking about the x's because technically this is a picture of just the x-axis. And then you're saying that all the answers are real numbers, meaning they're real numbers as opposed to complex numbers with i's in them. If you had i's, you would ignore them completely. So now you have to describe what's going on with this line. So you can say that x, I don't know how it changed colors. X is less than -1, so that's the space out here, or x is less than 3 at the same time it is greater than, reading backwards, 2. And that is your high school set notation. Now, I don't particularly like that, but because you probably have very limited background knowledge with university, that may take a while, even though in the end I think it's easier. So the first thing you have to do is you have to say this. So that says x is an element of. Just like up here it says x such that x is an element of the real numbers. That means we're talking about the x's. X's have to be real numbers. So this is saying x's have to be blah, 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 whatever it happens to be. So in this case, we're going from way out here to the left, which hopefully you realize is -infinity. And we're coloring all our way up to -1. Then we're taking a little break. Now, I'm not done here. We're starting our coloring back at 2, and we keep coloring till 3. And if you don't color in the circles, you get to put on force field brackets, sort of like this is a circle, so you're circling it. And infinities, either positive or negative infinities, always get a round bracket, so that's our statement. Now, without this here, that just looks like go over 2, up 3. So in order to make this 100% correct, you have to make sure that this is sitting there. And we're done. So we have one of 2 therefore statements, and in your booklet, you have both of them so you can do a comparison. So I'm going to do this exact same question, and I'm sorry for doing this. I'm going to do this exact same question a slightly different way. You can pick which way you do it, just like you can pick whether you long divide or synthetic divide. But I do have to tell you that regardless of your method, this stuff stays the same. So that means that regardless of your method, you are stuck doing all of this if it's not a Wayne Gretzky or shortcut question. So I am going to take a little break so I can set up for how we're going to do this in our second method, and then we will attempt a few other questions. Not necessarily all of them, but maybe all of them, because I have set this up pretty tidy like. So I'm going to leave it here while I take my little break. Holy smokes, 30 minutes. All right, back at ya. So the first thing I want to show you is what I did in the break. And you can tell that how much of a break I actually take, because you can see this, and you can see that I'm doing this at night, which kind of sucks. But I called it method 1, so I've labeled that, and you'll now know that I have, boom, method 2 over here. I also cut and pasted what I needed, which is exactly what I said I was going to need, and that is you pretending that it's an equal sign and then finding out that you have some roots. And the second thing I did was I made this bit a little bit smaller and I turned it red so that it stood out a little bit more. So those are some of the things I did. Now with method 2, which I like very much more because I think it's way less work, and it's way less work because you avoid all these silly checks, and that's what hurt my hand for the last question. But when the reason I do this is because you do need to know it for calculus, and because some people are going to like the check method better. I mean, all it is bed mass, so I'm just being a little bit of a baby when I say I like this way better. Now, this way, method 2, requires you to know everything you needed to know to graph or sketch a polynomial function. So with the information that we've got so far, I should be able to figure out, or I should be able to put on paper, this is the y-axis and this is the x-axis, and I've got an x-intercept of 1, another x-intercept of 2, and another x-intercept of 3, and there's no double roots and there's no points of inflection. They're all just order 1s, and I'm going to change that into x-intercepts. Another thing I need to do, the little bit of extra work, is finding out what the y-intercept is. So hopefully you remember that if you're graphing, it means you need an f at x, and to find a y-intercept, you put a 0 into all the x's. So you're substituting, and you end up with 6 as your y-intercept. So I can plunk that on the picture as well. And 6 is not down here, it's up here. And hopefully, because you're a really great grapher right now, you have a positive degree 3, and a positive degree 3 is a forward-shaped n, which totally makes sense with this picture. Remember, there are various degrees to how this can differ, but you generally have that picture, not knowing how low it goes or the slope of these, but that's generally the picture. Now, if I look at the original question, this says, blah, 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 my polynomial equation is less than 0. And less than 0 means negative. So I am looking to find all the places where this is negative. And specifically, y. And y is negative. Let's see if I'm going to do it with this one. Y is negative in all this space right here and all this space right here. But it's not negative here, so I throw a circle around it, and here, and here. So now, if I take a look at this picture, it looks an awful lot like this, meaning that I have colored on the x's, everything to the left of -1 and everything in between 2 and 3 on the x. So yeah, I've colored everything left of -1. Although it's down, it's still left of -1. If I draw a little line in here, it's left of -1 and it's between 2 and 3, not including any of the dots. So what I can do is I can totally cheat, and I can bring over, or in my case I can copy, the fact that x is less than -1 or between 2 and 3, and I can put in all the set stuff that I'm responsible for. There's your set notation, and then here is your interval notation. You are coloring all the way from way the heck down here at -infinity up to not including -1, or you are somewhere between 2 and 3, not including 2 and 3. And that's why I like this better, is because I did that in way shorter time. So I'm going to do a complete solution using method 2 for the next question, which I'm going to say is question B. So eventually I will work through all of these. I realize this may take an hour and a half, and you can fast forward through some of them if you like, or try it and compare your answer to my answer. Totally up to you. Okay, so I'm going to take a little break just to move some of these questions out of the way, put them on other pages, and then we'll come back and we'll get them in a sec. So pause time for me. All right, all set up and ready to go. So I'm not punishing myself with some horrendous questions over and over and over again. I'm a good little pre-planner, so I want you to know that this is a lightning bolt Wayne Gretzky question, and I planned it that way. So in the next line I am going to use equals, but I need to eventually come back to the fact that this is a less than or equal to 0. And yeah, you have to have the 0 there. So I've set all these questions up really well, except for that one. So we'll have to discuss what to do in this question because it doesn't have inequality 0. So with this question, I can take out an x squared from the first two terms and leave behind 2x minus 3. And in the back two, I could take out a 4, but because this is a negative, I need to take out a -4, leaving behind 4 times 2x is 8x. -4 times -3 would go back to being positive 12 equals 0. And then I've got the same bracket twice, so get used to me digging out my smiley face when that happens. Remember, if that doesn't happen, you either screwed up or you got to do the f at x long division synthetic division method. So we're going to haul that forward, and in a bracket behind, put x squared minus 4 is equal to 0. And hopefully you recognize that x squared minus 4 is a difference of squares. So we have that. And that means that our x's, which are x-intercepts, are 3 over 2, or -2, or 2. And I realize right now that I busted my trend. And because I want to use method 2, I'm going to take this statement right here, and I'm going to try to find the y-intercept. 2 times 0 cubed minus 3 times 0 squared minus 8 times 0 plus 12 is equal to 0 minus 0 minus 0 plus 12, which is 12. That's not going to make me happy. That's not going to make me happy. Now you know why some of these take so long. All right, time to put this on a pretty picture. So remember, what I do need from you is that you label your x and y axes and do a much better job than I did. So on this picture, I'm going to put 3 over 2, and 3 over 2 is 1.5, so it goes here-ish. I have negative 2, and I have 2, not to scale. None of them are double roots. None of them are points of inflection, because we had 3 distinct brackets for a degree 3 question. And then my y-intercept is positive 12. And this is a positive degree 3, so no surprise that we have that very, very popular N shape. Now, this question looks an awful lot, except for the numbers, like the last question, except I've done it all in one swoop rather than breaking it up like the last question. But this says not less than 0 like the last question. This says less than or equal to 0. So I'm still talking about less than 0 being in the negatives. But less than or equal to 0 means that I get to land on these points and I get to color them in. Sort of like I color them in method 1, if you remember back to that. So now I need to make either my high school or my university, my set notation or my interval notation statements, because I need a therefore statement. And if you miss the therefore statement, you will only lose 1 or 2 marks. The whole point is showing all your processes, knowing that you can do all this stuff. So the first thing I'm going to do, only because I have space and I don't know how to make this disappear without actually printing here, is I am coloring between 3 over 2 and 2, and I'm also including them, so I need that. That's a little bit different. Or, and then I'm going from negative 2 all the way left, so that means I'm less than or equal to negative 2. And then I get to put my fancy schmancy stuff in to make it look like a set notation. All right, so now let's do interval notation. So, interval notation makes me start with that to say my answers are x's, and I am coloring from negative infinity up to negative 2, and then I'm taking a break, and I'm going from 3 over 2 up to positive 2. Now, how is this different than just having the empty circles? Here's how it's different. If you color in a circle, you get a staple bracket because you are landing on things. That's how it's different. However, you never land on either infinity or negative infinity, so it always gets your force field round bracket. And there is your interval notation. All right, on to the next question. Fingers crossed that it's a Wayne Gretzky question. Can you tell by looking at it? Let's check it out. Don't trust me. If these brackets don't end up the same, we have to restart. Oh, they are the same. I better dig out my happy face. And once again, thankfully, I have a difference of squares. Now, something I do need to tell you is that I've chosen to maintain my symbol the length of this question instead of turning it into an equal sign. That doesn't change anything. It doesn't really matter. What matters is that you pull off the factoring. So either with the f at x or this way. I'm not going to forget my green line this time. And they're all going to be order 1, so when I go to graph this, sketch, I don't have to worry about double roots or points of inflection, and that's a really nice thing. Now, I found myself a little bit smushy in the last question, so I'm going to do my y-intercept here, and I want you to know that you can, if you're capable of getting the right answer, you can do some stuff in your head, like this green stuff. And like taking 0 and putting it in here and knowing that it's 0. And putting it in here and knowing it's 0. And putting it in here and knowing that term is 0. So you end up with 0 minus 0 minus 0 plus 4 is 4. So you could just tell me what you're doing, do it, and spit out an answer quite simply. So don't think you have to show all your work, but you certainly have to show the bulk of it. So you can see how I'm leaning towards this method. Even though I showed you the other method. The reason being, I assume some of you at least are going to calculus class at some point in your lives. And degree 3, positive, no double roots, no points of inflection, and shape. So, whoa, am I getting you to do things over and over and over again that are exactly the same? No, I am too smart for that. So first thing is I'm noticing the or equal to sign. So before I forget, I'm going to do that. But then I notice it's greater than or equal to. That means I'm looking at positives. And greater than or equal to means that I'm coloring up here because that's where the y's are positive. So you do have a switch in this question. And there's your picture. Don't forget that the point isn't to draw the picture. It's to draw the picture, either a number line or this, and then give me a therefore statement. So first therefore statement, look at how well planned I am this time. Set notation. We are coloring from -2 on the x's. Don't pay attention to this. It's a y. All the way up to 1. So that's less than 1, greater than -2, including both. Or we're coloring from more than 2, so greater than or equal to 2. The other option is, and I'm going to do a little funniness here as well because I want to teach you one other thing. We're coloring from -2 up to 1. Then we're coloring from 2 to infinity, and this is on the x's. So it's almost like this fell down onto that and this fell down onto that. And that's what creates a number line. So it's like a shadow effect. But here's what I want to show you. First of all, square bracket because we're landing, square bracket because we're landing, square bracket because we're landing. Infinities always get round brackets. Here's your little newness. That is a symbol for or. So you can't do this because that is not the symbol for or. It is a bowl, as in a soup bowl. cereal bowl. So don't have a stand on it. So I'm going to get rid of that. All right, so I'm going to take a little bit of a break because I just remembered that I have dishes in my sink. And yeah, it's 9:30. I still have dishes in my sink, and I can't even remember when I ran the hot water. So this is going to take me a little bit more of a break, so you can time me on doing my dishes, although likely I will be distracted because there's also a hockey game on. So I'm going to pause this. Okay, so first of all, I didn't actually do all my dishes. I think that was a whole 4 minutes. I did some of them, and then I let the rest of them soak. I don't have a dishwasher. I haven't had a dishwasher ever in my entire life because my parents didn't have a dishwasher. And I would like you to know that I do what my parents would absolutely kill me for, and that is I air dry everything. I don't know the last time that I actually dried a dish. I just do them at night and let them sit in the dryer and let them air dry, or I do them in the morning and then go to work and they're dry at the end of the day. So yeah, I think I'm pretty smart. Smart enough to do this question anyhow. So, does anybody know what to do? We don't have that 0. Yup, that's right. You pull that over. And then you think to yourself, oh, that tell us she's tricky. This is one of those keep it, change it, always plus difference of cube questions. So binomial size bracket, trinomial size bracket, I'm going to keep with the beak. Cube root of x cubed is x. Bop, let's try that again. Oh, I hate it when this happens. Square it. Cube root of 125 is 5. Square it. Multiply those two terms together in the center. Go back to the original question. It's a minus. So keep it, change it, always plus. Remember that you do have the option of turning that inequality into an equal sign. Oops, wrong page. The inequality into an equal sign and doing it using this method. However, I just got to basically here in one step rather than all of these steps because I am so smart. I recognize the pattern. And I don't make up a pattern when it doesn't exist. Another thing I recognize is that way back before, at least twice, I told you that this is not factorable, and I also told you that it is complex, meaning that you're going to get those i's not even graphable. That means not graphable on a number line. That means not graphable on a grid. So all I have to worry about is this guy right here. That is not to say that this degree 3 doesn't have 3 answers. It is a degree 3 and it has 3 answers. One of them is x equals 5 and 2 of them have i's in them. So it's just not graphable. So we're done that part. Whoa, that was easy. And now I'm going to go from that spot and I'm going to find the y-intercept. So I'm going to let x equal 0, and if I let x equal 0, 0 cubed is 0, minus 125, or minus 125 is negative 125. So a super negative, huge y-intercept that doesn't matter one bit because I am a sketcher. So I hope you can look at this and tell that I'm not even putting an effort into scale. I am putting an effort into numerical correctness. So if I go back to the almost original question, back to this star, again I have a degree 3. that means it's a positive degree 3 and I'm looking at an N shape. Now, you can make your N shape be whatever you want it to be as long as you don't make up any extra x-intercepts because you didn't find them. So let's get rid of that. And I'm going to do this. Even though I know that this picture actually looks like this. And it doesn't matter because whether it looks like this or whether I try to put it back to the other one, which I knew I wasn't going to be able to do that, it's still almost entirely under the y-axis. So now I'm going back and checking my starred line. Let's double star it. That says I am looking at the picture that is greater than 0, not equal to, greater than 0. And it's greater than 0 where it's positive, which is all this up here stuff. So if I'm looking to make my interval notation, set notation, I have colored greater than 5. That means every number that is greater than 5, when you insert it into the original question, will give you a positive answer. Only one spot coloring, only one statement, so no or is necessary. And then the other one is I'm coloring from 5 on the X all the way to the right, always a round bracket on any kind of infinity, a round bracket because I didn't color in 5 because I wasn't allowed to according to the question. So if I take any number bigger than 5 and insert it in here and do this math, I will get a number that is bigger than 0. If I take a number lower than 5 and put it in here, I will end up with a false statement. Also, if I take a number bigger than 5 and put it in here, I will end up with a number bigger than 125. But if I put in a number smaller than 5, so if I put in 2, I get 2 cubed is 8. 8 is greater than 125. Complete crap math, so you don't get to say that and it doesn't work. All right, so that one was short. I'm going to take a break and deal with those dishes, and I'll be right back. All right, I'm back. I've been doing 2 of these a night, trying to get ahead of you guys. That's not happening tonight. This is my last one. There's 2 more questions left, so I think I can keep this under about like 1 hour, 20 minutes, which is quite excessive. I apologize, but meh, whatever. Here's your next question. I really like this question. It's a degree 3. It's a positive degree 3. We're expecting an N. So, hey, I can't split this one in half. So I can't do the old Wayne Gretzky here. So, oh my gosh, it's not even a sum or difference of cubes because it's 3 pieces of information. And then I can't even do this because I don't have a constant in this question. Like, I've got an x cubed, and I've got an x squared, and I've got an x, but I don't have just a plain old number. That's the constant, and that's what you have to deal with. So there has to be a trick to this question. Because there's a trick, I'm going to choose to do this. And come back to the fact that this is an inequality. So here's the trick. If you have an x in every single one of your terms, that means this is a common factoring question. So I can common factor a single x out of all of these and look for a number which won't divide into all 3. So I can remove by common factoring an x and leave each position, each term, with 1 less x than before. And then I'm pretty sure that this is a complex trinomial that can't be factored. That does not mean you get to do this. Okay, you can only do this when you've got a sum or difference of cubes. So if you've got something that's not factorable and it's a trinomial and it doesn't come from a sum or difference of cubes, guess who's stuck doing the quadratic formula? Yeah, you. So quadratic formula time. Here it is again, in case you've forgotten. So x equals -4 plus or minus root 4 squared minus 4ac over 2a. Now you're hoping for an I under here, but I can't guarantee it until I actually take care of it. So this is 56 plus 16 is 2, carry the 1, 72. Nope, sorry about your luck. Let's erase my scribbles and practice my breaking down of square roots. So 9 times 8, 9 is a special number, it's a perfect square, but 36 is better. And if you need this better explained than just watching me do this, please ask. I'm happy to fill you in. So there is, whoa, 2 of my 3 x's. Where's my third? There it is. Now remember, this isn't a plus and minus sign, it's a plus or minus sign. So we have 0 as an answer, or we have the positive version of this, or we have the negative version of this. Now if you are absolutely 100% allergic to fractions, to roots, you can do this using decimals. So I am actually going to pause because I can't do this in my head. And I will, actually, hold on a second. I have a calculator. So I'm going to go from here because if I wasn't going to do roots, I wouldn't do any of this stuff. I would just get to that point. So 4 with a negative sign plus 72 under a square root equals, to finish off the top, then divided by 4 equals, so I get x equals 1.12. Clear? 4 with a negative sign minus 72 under a root. You're going to have to figure out whether you have to hit the root first or last with your calculator, equals, regardless of what calculator you have, divided by 4 equals, and I get negative 3.12, and then I still have 0. So one or the other, your choice. So I'm looking at this and I'm going, okay, well, if I have a 0, that means I'm not going to get any extra knowledge from my y-intercept. It's going to be 0. So I'm not even going to bother doing it. I'm just going to be super smart and know that degree 3's that are positive are n-shaped. So here's my 0. Here's my 1.12. And just to annoy some of you, that came from the positive version. And then negative 3.12 came from the negative version. And then I can do my N shape, and remember we have to go back and figure out what kind of inequality this was. So this was a less than or equal to. So here's the equal to's. And here's the less than, because you have to stay negative on the y. So let's attempt to make everybody happy. An impossibility. So I have colored less than or equal to negative 3.12. How's that for happiness? And then I have colored from 0, so greater than 0, bigger than 0, but less than or equal to 1.12. Other possibility, x's. We colored from negative infinity, not including it, up to that and including it, or fancy or 0 including it, up to that including it. All right, ready for the last question? No breaks for me. Time check. Whew. All right. Hey! Factored form. That means I don't have to do anything except race right on to finding my x-intercepts, or roots, or whatever you want to call them, solutions. So x equals 0. Order 1. Haven't done that before. Probably should have. X equals negative 1. Order 2. X equals 3 over 5. Order 1. All right. Can you tell which one it is? It's that one, not that one. We have a positive degree 4. If you are so smart that you know all that stuff, you aren't going to need to find your y-intercept. However, finding your y-intercept, as I've said before, but possibly not clearly, finding your y-intercept when your x-intercept is 0 is a complete waste of time. And it's a complete waste of time because 0, 0 would be dead center and you wouldn't get any extra information. So let's ignore the inequality for a second and see if we can get this picture drawn. So first of all, dots. So 0, 0. Negative 1, 0. 3 over 5, 0. And yeah, you're allowed to write 0.6 if you want to. I don't know why you would. Oh, double root. So that means at -1, I'm stuck doing the bounce like that or the bounce like that. So which one is going to make this shape instead of this shape? And I think it's green. So let's see if I can do it before I erase anything. This one is not a double root, so I scream on through. This one is not a double root, so I scream on through normally, and then I can tack my arrowheads on to say I'm going to keep going forever. All right, now I get to check the original question again to find out where I get to color. Oh good, I can have it all on the screen at the same time. So this is less than 0. So not equal to. Oh, this is easy. There's only one chunk that's less than 0. So all this stuff doesn't get mentioned. Set x such that x is an element of the real numbers from 0 to 3 over 5, not including either one of them. Or not that. That is bad. That doesn't really tell me anything as far as I am coloring from 0 to 3 over 5. This tells me I am coloring on the x from 0 to 3 over 5. So you absolutely need this sitting here. Your answers are for x's because your question was x's. That means any number that you pick that is between 0 and 0.6, when you substitute it in for all these x's, it'll give you a number that is less than 0. If you take any other number, so anything that is less than 0, if you take anything that is bigger than 0.6 and put it in for all the x's, you will get a number that is bigger than 0. So that makes that false. And if you end up putting either -1 or 0 or 0.6 in, you will get 0 is less than 0, which is also an incorrect statement because 0 is not less than 0. It's equal to it. So if there was an or equal to, you would be coloring them in and mentioning them in your therefore statement. So normally a 2-day note, but it's all one, and it's all page 34, and normally I would split it up into factorable and non-factorable. So I didn't do that this time. Remember, at any time you can review or do any of that other stuff, and good luck to you. I have no idea where my thing went.